So we will start with quick recap of some of the things we looked at in the first session. So we had understood the difference between scalars and vectors. Okay. That was the first thing we saw as physical quantities. So we had understood that vectors are quantities which have, so they are physical quantities which have both magnitude and direction. Okay. Whereas scalar quantities have only magnitude and no direction. Then we had understood next thing about notation. So we had seen that any symbol with an arrow on top of it is read as the vector quantity A, or whatever symbol, if it has a arrow on top of it, it is read as vector. And if I put it between two bars like this, it is understood as magnitude of the given vector A, like this. Okay. Whereas if we just have a symbol by itself without any arrow on top of it, then it is understood that it is a scalar quantity. Okay. So for example, you might represent force vector by the symbol F. But if you talk about magnitude of the force, we use the symbol mod F, or magnitude of F. So on and so forth, these kind of things. Alright, so that was about the notation. Then finally we had seen the important thing, the geometrical representation for vectors. And in that we had seen that we can represent a vector geometrically by an arrow, where if the arrow represents a certain vector A, let's say, the length of the arrow is directly proportional to the magnitude of the vector, and the direction of the arrow head that becomes the direction in which the vector acts. Just a moment, I still have somebody in the waiting room, I believe. No, everybody is here. Okay. Yes. Yeah, just to reply to your answer, to your chat message, this is the this part you don't need to write down, because I'm just giving you a revision of what we've done last time, and you will get the whiteboard notes also. So just understand these notes. Okay. When I give you some new definition and some questions to solve, I will give you plenty of time to write down. Okay, don't worry. Prince, this is to answer your question. Okay. This is just a quick revision of what we learned in the last lecture. Okay, so let's continue ahead. Okay. So the direction in which the arrowhead points, okay, that becomes basically the direction of the vector E, okay, so to speak. Okay. So to that end, we had seen all these things. So for example, we had seen that if we have defined some geographical directions like this, north, east, west, south, etc. Then, and in that, let's say we have defined a vector, one particular vector which is, let's say, like this. Another vector, let's say, like this. And another vector, let's say, like this. Let's say this is the vector C, and this angle here is 30 degrees. This is the vector E. Let's say that it's pointing in such a way that this angle is the perfect 45 degrees. And this is the vector B, let's say. Then according to the direction of the arrows, you can see over here that if I ask you what are the directions of vectors E, B and C from the diagram, you can see directly from the diagram that vector E points towards northeast. Okay. In fact, we can say 45 degrees north of east. This is exactly bisecting the northeast direction, so it's enough to say that it points northeast. Similarly, the vector B, we can see it points towards north. Okay. And likewise, we can see the vector C points in which direction? It's like this 30 degrees north of west. So it points at 30 degrees north of west. Okay. That's how we'll express the direction of these in words. What you can see in the diagram in terms of the direction of the arrowheads. So this is demonstrating how you can represent vectors in different directions by drawing arrows which are in different directions or in the corresponding directions. Okay. So just note down this example, and also in the example find out one more thing. Okay. So one was this. Second thing, find the angle between the vectors E and C. Okay, this first vector E over here and this other vector C, what is the angle between them? You have to figure that out. So the question is clear, people. Okay, just try this out. Yes, Divyam, correct. Very good. Rimjam, correct. Kushi, correct. Prince, correct. Kushal, correct. Akshat Vyas, you got the correct answer. Others, just be careful about the, yes, Achut, now you got it correct. Okay, just be careful about the calculation. So you can, as we discussed, the vector arrows are movable objects. So what we can do here in this is the vector arrow E that we had drawn earlier, somewhere here. As far as direction is concerned, it doesn't matter where A starts from and where E ends. Okay, so we can actually literally pick up this arrow and place it over here. As long as we don't change its magnitude and direction, the vector remains the same. So we can draw it from the origin instead now. Okay, so drawing it from the origin, it will look like this. Now similarly, we have drawn the vector C somewhere here like this. Okay. Just a moment. Okay. So we had drawn the vector C like this somewhere over here. So instead now we can draw the same vector over here. So draw it from the origin. As long as we don't change anything about the vector, in terms of magnitude and direction, it still represents the same vector. Now this vector was making an angle 30 degrees with this axis like this. And this was, of course, as you can see in the diagram, perfectly bisecting this. Okay. So now we are interested in this particular angle. This is the angle between A and B. This angle theta. Sorry, E and C. And that angle theta we can see is 180 minus the sum of 45 and 30. So that's 105 degrees. Okay, so this becomes the correct angle between the given vectors E and C, because this vector is pointing 45 degrees north of east and this vector is pointing 30 degrees north of west. So we can see that the angle between A and C will be taken as this angle. You might also say that, okay, why can't we express the angle as this? And we can express it. And this one will simply become 360 minus 105 or okay, 255. But the thing is, we always take the smaller of the two angles. Rather than the larger one, we take the smaller of the two angles. So that's why here we will typically express the angle theta as 105 degrees. Okay. So hope this example is clear to all of you people. So these were some of the things that we learned in the last lecture. Okay. Now moving on, we will start looking at vector operations or algebraic operations involving vectors from the geometrical representation. So the next part of this vector analysis is vector operations. Or you can say vector algebra. So of course, this is with respect to the geometrical representation of vectors. Okay. You can say all this is by geometrical method for representation. Okay. So the first operation we will learn, yeah, we'll explain that, we'll come back to that question. Okay. So the first operation we will learn is multiplication of a vector by a scalar. Okay. For example, we have one of the most famous equations in physics. Net force acting on a particle is mass into acceleration. So in this you can see the left hand side is a force vector. The right hand side, mass into acceleration, is a product of, in this m, which is the mass, is a scalar, and e, which is acceleration, is a vector quantity. So this is a practical example of the application of this type of operation, multiplication of a vector by a scalar, this kind of. Okay. So what happens when we multiply a vector by a scalar? So if we have a general equation like this, that the vector b is equal to n times the vector e, okay, where n is a scalar, then there are two cases. If n is a positive scalar, then the magnitude of b is equal to n times the magnitude of e, and direction of b is along e. So let's understand this with an example. So don't worry, I'll give you time to note this down. Okay. So example, vector e is as shown in the diagram. Okay. Now construct vector b such that, let's say b is 3 by 2 times e. Okay. So suppose this is a question that's given to us. Vector e is constructed like this for us, and it is now showing that construct the vector b such that it holds true according to this equation. Okay. So what we'll see in this is that so given that b is equal to 3 by 2 times e. Okay. So it is an example of a vector is a scalar times another vector where n is a positive quantity. So that means magnitude of b will be 3 by 2 times magnitude of e. Okay. And direction of b is, you can say, parallel to, that's the same thing as saying it is along the vector e. So if the vector e was given to us like this, now the vector b will have to become something like this. It will have to be another vector which is parallel to this but 1.5 times in length. Okay. This is the definition better. Okay. If a vector is a scalar times another vector, if b is equal to some number or any scalar quantity into e, where that scalar quantity is positive, so then by definition positive hai matlab ye parallel ho jayega. So that is okay. So in this diagram you can see where mod b is 1.5 times magnitude and their directions are parallel. Okay, so I'm just minimizing all this. Just first note down the definition of the operation itself and then come back to this example. So this is the first type of algebraic operation that we are learning using the geometrical method, that if what happens when you multiply a vector by a scalar quantity. The practical example being F is equal to ma Newton's second law, but we are also taking another abstract example below. Okay, so in that what we are learning is in multiplication by a scalar, there are two cases actually. Okay, one case is when that scalar is a positive quantity, which we are seeing below over here. This case. We'll also see a case where n can be a negative quantity. Okay, but in general, there are two cases like this. Okay, Medhanj, if you are experiencing any internet connectivity issues because of which voice or video or whatever is not okay, don't worry. This is a recorded session, so you will get the recorded version of this, and you can catch up on any part that you missed out because of internet connection issues. Okay, so hope this part is clear. Okay. So just repeating, we are looking at the operation where you multiply a vector by a scalar quantity. So there are two cases of that. The first case is if the quantity we are multiplying is a positive quantity. So if b is equal to n times a, where n is a positive scalar, then what happens? The magnitude of b is n times a, and the direction of b is parallel to a, okay, or it is along a. Parallel to a is the same thing as along a. So this is the first part. If it is a positive quantity. Okay. So the example of this is over here below. So this is the complete solution of that example. Okay, hope this is clear. Now next we'll see what happens if n is a negative quantity. So the second case, if n is equal to a negative scalar quantity. Okay. For example, charge in physics is a scalar and can be positive or negative. So there are certain type of physical quantities which can be positive and negative in spite of being scalar. Whereas there are other physical quantities like mass, volume, etc., which don't have algebraic sign. We don't say mass is positive or negative. We just say mass is an absolute quantity. Okay. So what happens if the vector b is n times the vector a such that n is a negative scalar? Then the direction of b, instead of being parallel, it becomes opposite or anti-parallel. So opposite is also referred to as anti-parallel. So that's about the direction. And the magnitude of b becomes, now because n is a negative number, so we have to put n also with a mod times this. So just note down the second case, then we'll understand with a couple of examples. Okay, so let's understand with an example. So given that vector E is a displacement of 50 kilometers at 30 degrees north of east. Okay. Draw vector arrows to represent Okay, so try this question out based on what we just learned. Yes, Aman, correct. aspirants correct. Aman correct. Okay, Rimjim correct. So you can see here that in this particular case, if we redraw vector E like this, and express that it has a magnitude of 50 kilometers along this direction, which is 30 degrees north of east. Okay. Now, since it is given to us that the vector B is minus 2 times the vector E, so what this means that the magnitude of B is twice the magnitude of E. So that means it is 100 kilometers. And B's direction is opposite that of E. So it will be like this, 30 degrees south of west. That's over here. Because the diagram you can see, we'll have to draw vector B like this now. Just roughly double the length. It has a magnitude of 100 kilometers. But exactly opposite to this, which means this angle will be 30 degrees. So that's how it's ending up like this. So this becomes the vector B. Whereas if you talk about the vector C, C is 0.6 times A. So that means the magnitude of the vector C is 0.6 times, that's 30 kilometers. And C is along the vector A, or parallel to it. So we can draw vector C just on top of A here also. We can draw it separately here also, it doesn't matter. As long as we are showing that it's a parallel line to this. So this angle is also 30 degrees. So this becomes the geometrical way of representing B and C on the basis of those equations. Okay. And this becomes them in terms of direction. Okay. So C is again 30 degrees north of east. So this is the complete solution, people. Just make a note of this quickly before we move on to the next operation. Okay, so I hope this is clear. Now, Rimjam, just to answer your question and just explain the two directions you asked. We have one vector. E is 30 degrees north of west, suppose. Then how that vector looks in the geographical sense, it will look like this. Point like this, where this angle is 30. Okay. Because from west, you're going towards north, 30 degrees north of west. So it will be like this. Okay. Now suppose I have another vector B, which is at a direction of 30 degrees west of north. And you'll see that's not the same. Okay. In that case, what we are going from north, we are going towards west by 30 degrees. So in fact, the vector B will be something like this, where this angle will be 30 degrees. Okay. So 30 degrees west of north, this is the same as 60 degrees north of west. Okay. Because that's the same thing as saying that this angle is 60 degrees. But this and this are not the same. Okay, so Rimjam, hope you understood this particular thing. The difference between 30 degrees north of west and 30 degrees west of north. Why they are not the same? This is the reason. Okay, 30 degrees west of north can also be expressed as 60 degrees north of west, but it cannot. It's not the same thing as 30 north of west. Okay, good. So this is about the first type of operation we saw. Okay, which is multiplication of a vector by a scalar. So now moving on to the next operation, but before that, just a special case. If the vector B is equal to n times the vector E and n equals to 0, okay, then the vector B becomes what we call, it is a null vector. Okay. That means it is a vector of magnitude 0, which is denoted by this symbol. Okay. This symbol is the one used for a null vector. And the definition of a null vector is it's a vector of magnitude 0. So this is just a special case. Just make a note of this. We've seen what happens when you multiply a vector with a positive or a negative quantity. But what if you multiply it with 0? If you multiply it with 0, this is what happens. It becomes what we call a null vector. Okay, next up, we will see an important vector operation. It is the addition of two vectors. By something called triangle law of vector addition. So, given vectors A and B, okay, such that magnitude of the vector A, let's say we denote with the scalar quantity capital A, magnitude of the vector B, okay, and the angle between them is theta. So these three quantities are known. The magnitudes of the two vectors and the angle between them. Then how to find what is called their resultant sum, which you can denote with the symbol R, such that R is equal to A plus B. Okay. So how to find this? Let's understand. So just note down the heading, then we'll continue. Addition of two vectors by triangle law method. Okay, so let's understand this method. Okay, so suppose the vectors A and B which are given to us are these two. This arrow represents vector A and this arrow here represents vector B. Suppose. This is a vector A and this is the vector B. And if we were to extend this direction along this, see this is angle theta. So magnitude of the vector A is a known quantity, magnitude of the vector B is a known quantity, and the angle theta is known. Now how would we find the resultant sum of the two vectors? So what we'll do is we'll interpret the resultant as if we are treating A and B like two displacements. Okay? So just imagine here that the vectors A and B are two displacements. So if A is a displacement vector, that means if I start from this position, after completing the displacement A, I reach here. And if B is a displacement vector, then again it means that if I start from this position, then after completing the displacement B, I have reached over here. So that being the case, just a moment, people. Somebody is trying to join the meeting, Dushyant, and unable to join. Just give me a second. Clear the waiting room. Yeah. Dushyant, are you online? Can you just reply my chat with a chat message? Dushyant, have you managed to join the meeting from the waiting room? Dushyant, if you are online, then just reply by text message. Okay, let's try to continue anyway. Okay, so coming back here, these two vectors A and B are known to me in terms of I know their lengths and I know the angle between them. Then how would I find the resultant sum of A and B? So the thing is, just imagine as if A and B are displacement vectors. So what does the operation of A plus B mean? So let's say you're starting from this position over here and you compute first the displacement of E. So that means you pick up this vector here and place it from wherever your origin was. Let's say this was your starting point. From that you draw the vector E. So you reach this position. But now you're doing the displacement of A followed by B. So after completing the displacement A from this initial point to this final point, next you're doing what? You're completing this second displacement B. So from the head of A, you now have to draw the second vector B, because that's the second displacement you are completing. You'll just pick up that B vector's arrow from there and place it over here, such that it just starts from where A ends. And of course, here this angle is theta. Just extend this line, you know, this particular angle is theta. So now what in this diagram, what is my resultant sum of the two? So resultant sum of the two, just imagine A and B are displacements. So this is where you started from. Then you completed the displacement A, then completed the displacement B, and you reached here. So what is your final displacement, the sum of these two? The resultant displacement, it is just the line joining the initial and the final position. So that becomes this one. So that is why this is called the triangle law, because we construct what is called a vector triangle using the vector arrows A and B. And in that vector triangle, A and B become the adjacent sides, one after the other of the triangle, and the resultant becomes the third side. Okay. So now we will use trigonometry and, just a second, we'll use a combination of trigonometry and Pythagoras theorem to find the magnitude of R. So next what we will do is within this triangle, so this quantity becomes the length of the third side of the triangle. So let's see how we'll calculate the length of that third side. So let's draw that triangle once more. Let's try to understand how we can construct this. So now in this triangle, I know that this side is nothing but magnitude of vector E. This side is magnitude of vector B. And this angle here is theta. And this side is magnitude of the resultant, which I have to find out. Okay? Okay. So how to find this now? Now, if this side is y, okay, and this side is x, then by using trigonometry in this right angle triangle, you can see that the hypotenuse is the quantity B. Okay. And this angle is theta. So we can just make use of trigonometry that cos theta is base upon hypotenuse. So we can denote the quantity x over here as B cos theta. And similarly, sin theta is perpendicular upon hypotenuse. So we can denote the quantity y as B sin theta. So once I have the value of x and I have the value of y, you can see that in the larger triangle, for which R is the hypotenuse, this side length is A, this side length is x. So the whole base is becoming how much? The whole base is becoming A plus x, this part. And this is y. So we can calculate R as the hypotenuse of the larger right angle triangle and get the value of magnitude of R from that. So just make a note of this part first. Okay. So this is solving the smaller triangle. Okay, this triangle. For this triangle, yeah, cos theta and sin theta. So from that you are getting the value of x and you are getting the value of y. Just make a note of this first, x and y. Then we'll solve the larger right angle triangle, and from that we'll get the magnitude of R, that is the third side. Okay, so hope this part is clear. How we got x and y from here. Now next we'll see how we'll solve the larger right angle triangle to get the magnitude of R. Okay. So now in the same triangle, we now want to find out this side, whose magnitude is R. So you've already seen that this side is B sin theta. This here is B cos theta. And of course, this here is A. This was B. And this angle is theta. Okay. Now I'm talking about the larger right angle triangle. So if you look at the larger right angle triangle, I'm just drawing it aside over there. This is R, this is Y, and this is E plus X. This is becoming E plus S, this whole base. So I can see that magnitude of the resultant should become square root of the base square plus the perpendicular square. So now just substitute the value of x as b cos theta and the value of y as b sin theta, and now expand this. Okay, use algebra to expand this and you'll see it will reduce to something much easier. Okay, so just continue this simplification ahead and see what you get. You'll get the yes, Anmol, that is correct. Okay, so continuing the algebra here, we can see that what you will get is, so next step, you would expand this is a square plus 2ab cos theta plus b square cos square theta, and then we also have this term, so plus b square sin square theta. So between these two terms, you can use the identity that cos square theta plus sin square theta is unity. So we get the standard formula
the magnitude of the vector sum of A and B becomes square root of A's magnitude square plus B's magnitude square plus 2 times AB cos theta. So this is the statement of our triangle law of vector addition. Just minimizing this so that you can see the steps involved. No, Prince, we cannot reduce it to A plus B whole square. Because there's a cos theta term. Okay, so let's understand this with a couple of examples. So for example, if mod A is equal to mod B is equal to 20 units, okay, and the angle between A and B theta is equal to 60 degrees, then find the magnitude of A plus B. Okay, so let us understand this directly by formula now. So by application of triangle law, magnitude of A plus B just by formula become root of A square plus B square plus 2AB cos theta, where we'll substitute A equal to 20, B equal to 20, and theta equal to 60 degrees from over. So this direct substitution when we do, let's see what we get. Two into A into B into cos 60 degrees, where we'll use the standard value which we know that cos 60 degrees is half or 0.5. So this becomes just substitute cos 60 as half, so you'll get this also as 400. So you will see that get this as 20 root 3. So this becomes the magnitude of the resultant of here. So this is how you are supposed to, directly apply the formula of triangle law of vector addition, given any situation like this. So I'll just leave this for a moment for you to copy. Then we'll do one question where you will work it out yourself. Yes, Aman, that's correct. Anmol, Aman, Akshat, all of you got this correct. And yes, you can, next step, you can approximate root 3 as 1.73, something like that, 1.732. Okay, people, so this should be fully clear. Now let's look at one example for you to solve. So in this, let's say the vectors are given to me geometrically. So vector A is of length 10 units. And vector B in comparison, let's say something like this. Now B is of length 30 root 2 units. Okay. And this angle is 45 degrees. So the magnitude of A is 10, magnitude of B is 30 root 2. And as you can see, this angle theta is 45 degrees. So we want to find this. Just work this out quickly, people. Aman, your answer is correct. Okay. Uday, check your calculation once. So Aman, your answer is correct. Uday, you'll have to check your calculation. Yes, all of you got this correct. Rimjim, Divyam, Akshat. Anybody else I missed? Prince, correct. Khushi, just check your answer again. Okay. So just use the standard value here. So use the standard value that in the formula substitute okay. So substitute A as 10, B as 30 root 2 and cos theta as cos 45, which is 1 by root 2. So just use this here. To AB cos theta. Let's use this. So this will be 100 plus 30 root 2 whole square will be 900 into 2. So that's 1800. Plus in this the root 2 will cancel out. So we have 2 into 10 into 30. So that is 600. You can see that will become square root of 2500, which is nothing but 50 units. Okay. So this becomes a mod A plus B. Okay, so hope all the steps are clear. Right, so hope all of you understood this. Yeah, Dushant, I understand you missed the class for some time because you're not able to enter from the waiting room. So don't worry, just go through the video recording of the lecture afterwards. So you'll get the part that you missed. Or in case anybody has missed part of the first lecture also, it's there for the video recorded version is there on our channel. So you can go through it. Okay, next up, we'll see how to find the direction of the resultant. How to find that? Okay. So coming back to our vector triangle, we have found out the magnitude of the resultant vector. If we were adding vectors A and B, and that was giving us this resultant vector. Now we need to also find out the direction of this vector, which is the resultant of A plus B. We've seen how to find out the magnitude. Okay. But what about the direction? That's the next thing. Okay. So for the direction, what we'll do is we'll find out this angle alpha over here. Okay. So we'll express the direction in terms of alpha. That is the angle made by the resultant vector R with respect to the vector A, where we understand R is A plus B. Okay. So coming back to this triangle here, See, this angle was theta, this was x, and this was y. And this length here was the magnitude of the vector E. So again, now what we need to do is apply trigonometry to the larger triangle to find alpha. So for the larger triangle, you can see that tan alpha is equal to, so tan alpha in this is nothing but perpendicular of the larger triangle, which is y, upon the base, which is a plus x. So now just substitute x and y from what we got earlier. So tan alpha is b sine theta upon a plus b cos theta. This becomes the formula for the angle or for the direction of the vector r with respect to the vector E. So just note down this formula, people. Okay, so let's see how this is applied. So we finished with writing this down. Next up, let us see how this is applied to find the angle. So going back to that previous example we had seen, suppose mod A is equal to mod B is equal to 20 units and theta, the angle between them was 60 degrees. Now we want to find the angle made by the resultant with respect to the vector E. Let's understand how this comes. Okay. So for this, we will just use the formula. Okay. Where we should not get confused about the two angles involved. Alpha is the angle of the resultant with respect to E. Whereas theta was the angle between A and B. Okay, so theta here is the angle between A and B. Whereas this angle will be substituting as alpha. So now let's just substitute the values here. So in this case, tan alpha will become b sine theta. So that is this divided by a plus b cos theta. So that is 20 into root 3 by 2 divided by 20 plus 22 half. Okay. So we can further simplify this and write this as root 3 divided by 3, because this would have become so that is 1 by root 3. So that we know is a standard case. Alpha is 30 degrees. Okay, so this kind of thing is again very straightforward. It is just direct application of formula. Correct. Kushali, you got this correct. Okay. Akshat, Aman. Got this correct. Okay, so just go through the calculation carefully once. Now, next thing what we'll do is we'll also visualize how the triangle exactly looks. Yes, Prince, you got it correct now. Okay. We'll also look at how the particular vector triangle looks for this case, mod A equal to mod B equal to 20, and the angle between them 60 degrees. And from that also we'll be able to analyze, okay, how exactly we are getting the results we are getting. Okay, so let's also try to understand how we can justify this using the vector triangle. So if we were to draw the vector triangle for r equal to a plus b, in this case, it would look something like this. Now there would be a certain degree of symmetry in this triangle, which would help us find out this angle. This angle is alpha. And this angle is the known one. It was 60 degrees, whereas the magnitude of A was 20. The magnitude of B was also 20. So you can see that this particular triangle, it is an isosceles triangle, where magnitude of A is equal to magnitude of B equal to 20. So this side is equal to this side. So automatically what happens? This angle becomes equal to this angle. Okay. And then we have the thing that sum of interior opposite angles is equal to exterior angle. So we would have had this. See, this is justifying this. All right. So this is another way of understanding the same thing. Okay. Without using the formula, but in this case using the symmetry of the isosceles triangle. Now, had the symmetry not been there, had the magnitudes of A and B not been equal, then we could not have used this method so easily, because these two angles would not have been equal. So this would not have worked. So the general method is still the formula-based method, but in certain cases like isosceles triangle or right angle triangle or things like that, it becomes very easy. Okay. Let's take another example to understand this now. Magnitude of the vector A is, let us say, 10 units, and the magnitude of the vector B is, let us say, 10 root 3 units, and theta is equal to 90 degrees between A and B. So if R vector represents the resultant of A plus B, and we want to find magnitude of R and the angle of R with respect to A, first of all, by formula method and geometrically. Both the methods are easy here. Just try this out with me. Yes, that's correct. Akshat, your answer is correct. Okay, so all of you are getting this correctly. I've got many people giving me the right answer. Okay. Aditya, Prince, Dushyant, Kushal, Arvinda, Nishchal, okay, Uday, Rimjim, all have got the correct answer. Aman earlier, okay. So I'm just going to apply both the methods first over here. Substitute this here. It becomes very obvious that the magnitude of the resultant, this, okay, and then use the formula tan alpha b sin theta upon a plus b cos theta. So that is 10 root 3 sine of 90 degrees upon 10 plus 10 root 3 of cos of 90 degrees. This becomes 10 root 3 by 10. That means alpha is equal to 60 degrees. So this and this become the answer by the formula based method. So very straightforward, as you can see, nothing difficult here. Okay, so hope you understood this method. Okay. Let's also see this by the geometrical method. This is a very simple triangle when we draw it. It's a right angle triangle like this. So makes life very easy. this is the vector A, its magnitude is 10. This is the vector B, its magnitude is 10 root 3, and the angle between them is 90 degrees. So then the triangle that we are drawing to find the resultant, that only is a right angle triangle. As you can see, that this is you can see that you can see that tan alpha so again all very straightforward because theta was 90 degrees. Okay, now next up, for more complicated applications, we will see a couple of more things here. One is some standard right angle triangles, which you should always keep in mind. So first up, we have the 30, 60, 90 triangle where the ratio of these sides is such that if this is 2, this is 1. So you have sine 60 is root 3 by 2. Cos 60 is half. And tan 60 is root 3, which you know already. Now if you just invert this triangle, it becomes this one, the 30-degree triangle. What is the base is root 3. Okay, so this sine 60 becomes the same thing here as cos 30. This triangle you can see cos 30 is the same as sine 60 here. And this becomes the same as sine. And this becomes the same as cot of it. Okay, so this is the 30, 60, 90 triangle. So this is standard. All of you already know this. Now one which is not so standard and which you'll have to keep in mind from now on is this next one. This is a 3, 4, 5 triangle, or the 37 degrees, 53 degrees, 90 degrees triangle. So here this angle is 53 degrees and this angle is 37 degrees. Okay. So just some new values for you to learn. Sine 53 is 4 by 5. Cos 53 is 3 by 5, or you can write this as 0.8, this is 0.6, and consequently tan 53 is 4/3. Right. So now also the inversion of this one is this triangle now. So if this right angle triangle is such that these sides are again in the ratio of 5:4:3, and this angle here is 37 degrees, this angle here is 53 degrees. So if you look at these formulae alongside now, you see that sine 53 is the same as cos 37. And cos 53 is the same as sine 37. And tan 53 is the same thing as cot 37. So this becomes 3/. Okay. So these are some new values for you to learn. So make sure you remember these because these are used in physics and particularly in vectors application a lot. So suppose to memorize these values for sine, cos and tan of 53 and 37, just as you know for 60 and 30. And of course 45 also you know. Okay, so just make a note of these values. So this is not derived from something else. It's just a factual matter that if you draw a right angle triangle with the angles 53, 37 and 90, the sides are in ratio 3:4:5. If you actually use a protractor and draw a triangle like this and then measure the sides, you will see that the ratio is such that sine 53 comes out to be 0.8, cos 53 comes out to be 0.6. All right, and of course you know the standard one, which is the 45-degree triangle. So there is no need actually to go through that one again, but anyway. So the 45-degree one is such that this side is equal to this side. If these sides are unity, then this side is √2. So you know that sine 45 degrees becomes equal to cos, which is 1/√2, and tan 45 is equal to cot 45, which is unity. Okay. So these three types of triangle should cover everything. The 30, 60, 90 type of triangle, the 37, 53, 90 type of triangle, and the 45, 45, 90 or the isosceles right angle triangle. This is also called the isosceles. Okay. Now a couple of more things. So for example, that question we had done earlier, where one vector was 10 units like this and the other vector was 30√2 units like this, and the angle between them was 45 degrees, and we had just found out the resultant in that case and seen that that was 50, but now we'll also find out the angle that the resultant is. So if this angle is alpha, so if magnitude of vector is 10 units, magnitude of vector B is 30 root 2 units, and theta is equal to 45 degrees, then find alpha. Just work this out. Magnitude of R we had already seen earlier in that question, it was 50. But now we want to find the angle that the resultant is making with A. So that is the angle alpha in the diagram. So just work it out. Correct. Very good, Aman. That is correct. Yes, Kushi, that is correct. Very good. Arvinda, correct. Very good. So all of you are getting this correct. So we'll use the formula. Tan alpha is B sin theta upon A plus B cos theta. So that here will be 30 root 2 into sine 45 degrees upon 10 plus that is this. So to just patiently work out the calculation, there's nothing more to this actually. Okay. So if tan alpha is 3 by 4, then going back to the other triangle, the 37, 53, 90 triangle, you'll see that alpha is 37. Because this one, see, the tan 37 is 3 by 4. So we're making use of this table of values below. That's how alpha is 37. Okay, so just make a quick note of this in case you haven't worked this out. Yes, Uday and Prince, you got it correct. Dushant, you got it correct. Just you given the value of tan alpha. Now from that alpha is working out to be 37. Okay, so hope this was clear. Now just one final thing for today, we'll see. So we are at the conclusion of the lecture, but one final thing we'll see, that what to do if theta is an obtuse angle. So for that, what we do is we make use of this formula. Use the formulae, the trigo formulae, which you might be studying right now, that cos theta is minus of cos 180 degrees minus theta, sin theta is positive of sin 180 minus theta, and tan theta is again negative of tan 180 minus theta. These are the formulae we use when theta is obtuse. So it is greater than 90 degrees but less than equal to 180 degrees. Okay. So I will explain the interesting way of understanding these formulae also in the next lecture. But as of now, you first get used to applying this formula. So just note this table down first, this set of formulae. Then we'll see a couple of examples and it will become clear. Okay. So for the moment, don't worry where the formula has come from. It's just a trigonometrical formula. We'll just look at. Khushi, you should have got the module of vectors. In case you haven't got, then you can a message to either Rahul sir or Anu ma'am, and they will forward you the PDF, okay, of vectors. It is a booklet called the Mathematical Tools of Physics. Okay. I'll just check. In case your entire group has not got, then I will forward it to you. Whereas individually, if I haven't got, then just drop me a message. Those who haven't got the vectors booklet, now just drop me a message once on WhatsApp. I will send it to you. Okay, so however many people have not reached got the vectors booklet now, just drop me an individual message on WhatsApp. Okay, not on the group, just an individual message. I'll send it to you. Okay, so let's look at an example. Find example cos of 120 degrees, sine of 120 degrees, cos of 150 degrees, sine of 150 degrees. Okay. So in each of these, I'll show you one of them. Then you can do the rest. Use the formula. So cos of 120 will become minus of cos 180 minus theta. We are using this formula that cos theta is minus cos 180 minus theta. Okay. So that is minus cos 60. So it's minus half. Similarly, you can use the formula sine of 120 will be positive of sine 180 minus 120. That is sine 60. So that is root 3. Okay, hope this is clear, people. Okay, so likewise, when you work this out, you will see that your cos 150 degrees should come out to be minus cos 30. So it should be minus root 3 by 2. Whereas your sine 150 degrees should be positive of sine 30. So it should be half. Correct. Okay, these are the values. So now, as a quick application example, we have something like this, let's say. Okay. So this angle is an obtuse angle, let us say. Okay. So magnitude of vector A, let us say 10. Magnitude of vector B, let us say is 20. But the angle between them is, let's say, 120 degrees. Okay. So find so just try this out using the above formula.
Yes, Aman, that is correct. This is correct answer. So here we just use the formula. So this is the root of a square plus b square plus 2ab cos theta. But in the formula, we'll substitute cos theta is how much? Cos 120. So here, this above is minus. So this becomes the root of a square plus b square plus 2ab cos theta, which is minus half. So this becomes the final form. I mean the final solution. Okay, so as I said, as of now, whenever we are having an obtuse angle, just use the two formulae for sine theta and cos theta which I have given you. Now, the justification of the formula and the logic of it we'll understand in the next lecture, because there's a very nice way to understand it from vectors. You might have studied it as a direct formula in trigonometry, but the derivation and how it comes also, there's a nice way to understand that from vectors. Okay. So people, that's it for today's lecture, and I will be giving you a worksheet for today's lecture, which I will send in the group. It will be worksheet 1 for vectors, so make sure you attempt those questions and discuss them with me through the week before our next lecture in the next week. Okay. And also, those of you who haven't received the booklet, don't forget to message me. I'll help you out. Okay. That's it for today's lecture, guys. See you.